Selling your car to Carvana is as easy as...
As easy as pie?
Sure. All you have to do is enter your license plate or VIN.
As easy as a stroll in the park.
Okay, then just answer a few questions and you'll get a real offer in seconds.
As easy as singing.
Why not? Schedule a pickup or drop-off and Carvana will pay you that amount right on the spot.
As easy as playing guitar.
Actually, I find that kind of difficult. But selling your car to Carvana is as easy as...
Can be.
Visit Carvana.com or download the app to get an instant offer today.
With Starbucks Holiday Blend for Nespresso Virtuo, now exclusively at Target, there are even more ways to share the joy. Savor every smooth and festive sip all holiday season with friends and family at home to fill every indulgent day with cheer.
This is SpaceTime, Series 19, Episode 77, for broadcast on November the 2nd, 2016. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, discovery of recent volcanic eruptions on Venus, the origin of Rosetta's famous comet, and growing evidence that China's getting ready to fly its new Long March 5 heavy lift rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new analysis of data from the European Space Agency's Venus Express mission has found evidence of volcanic activity in the planet's recent geological past. The findings add to a growing body of evidence that Earth's twin planet may still be geologically active. Venus is often called Earth's sister planet. They're almost the same size, Earth just a little bit bigger, and they were both born in roughly the same part of the solar system under similar conditions, giving them both a similar chemical makeup and composition. However, if Venus is Earth's sister planet, then it's somewhat of a twisted sister, with average surface temperatures of over 460 degrees Celsius, hotter than the planet Mercury, and hot enough to melt lead. Venus also has a crushing atmosphere, with almost 100 times higher barometric pressure on the planet's surface than Earth. That atmosphere is almost completely composed of carbon dioxide, over 96%, resulting in a runaway greenhouse effect which has quite literally superheated the planet and evaporated away all the planet's water. When it does rain on Venus, it rains sulfuric acid, and metallic snow covers the mountain peaks. Venus is cloaked in a thick blanket of carbon dioxide and sulfur clouds. The surface of Venus shows evidence of extensive volcanism, and sulfur levels in the atmosphere indicate fairly recent volcanic activity. In fact, about 80% of the Venusian surface is covered by smooth volcanic basaltic plains. There are two highland regions described as continents which make up the rest of the surface area. One lying in the planet's northern hemisphere, the other just south of the equator. The northern continent is called Ishtar Terra, Ishtar being the Babylonian goddess of love. It's about the size of Australia. Maxwell Montes, the highest mountain on Venus, lies on Ishtar Terra. Its peak is 11 kilometres above the Venusian average surface elevation. The southern continent is called Aphrodite Terra, after the Greek goddess of love. It's the larger of the two highland regions, roughly the size of South America, and is covered in a network of fractures and faults. Venus has few impact craters, indicating the planet's surface is relatively young, between an estimated 300 and 600 million years. That means there's been lots of resurfacing going on. Unlike the Earth, there's no evidence of tectonic plate activity on Venus to remove internal heat. However, Venus does have some very unusual and unique surface features, including flat-top volcanic features called phaera, which look a little bit like pancakes and range in size from 20 to 50 kilometres wide and from 100 to 1,000 metres in height. There are also these weird radial star-like fracture systems called novae, features in both radial and concentric fractures resembling spiderwebs known as arachnoids, and coronae, circular rings of fractures sometimes surrounded by a depression. These strange features are all thought to be volcanic in origin and may explain how Venus gets rid of its internal heat. Now, a new study of Venus Express observations of the planet's southern hemisphere by planetary scientists with the German Aerospace Centre DLR have revealed some fascinating results. Venus Express studied Venus between 2006 and 2014, analysing the planet's atmosphere and surface features. The research team examined data from the probe's visible and infrared thermal imaging spectrometer. The thick permanent cloud cover of Venus has until now limited achievable resolution. It's a bit like looking at the view through fog. However, by running the existing data through a new numerical modelling technique, the team were able to push the limits of data resolution to better analyse the top and eastern flank of a massive Venusian volcano called Indan Mons, a giant mountain in the southern hemisphere with a base diameter of over 200 kilometres. These anomalies have provided scientists with an indication of geologically recent volcanism in the area. In fact, the scientists could clearly identify and map distinctive lava flows from both the top and eastern flank of the volcano. The new technique combined the Venus Express infrared data with much higher resolution radar images from NASA's Magellan mission, which orbited Venus between 1990 and 1992. This was the first time that, combining data sets from two different missions, allowed scientists to perform high-resolution geologic mapping of a recently active volcanic structure on the surface of a planet other than Earth. A new study claims Rosetta's comet, 67P Churyumov-Gerasimenko, most likely originated in the Kuiper Belt. On August 6, 2014, after a 10-year, 6 billion kilometre journey, the European Space Agency's Rosetta probe made history by becoming the first spacecraft to enter orbit around a comet. Then, on November the 12th that year, Rosetta made history again, deploying the Philae lander, which became the first spacecraft to soft land on the surface of a comet. Although, as we later found out, that landing was a bit too soft. Things didn't go quite to plan, with the lander bouncing across the surface several times before eventually ending up in a ditch. Rosetta's mission finally drew to an end with a suicidal death plunge under the surface of Comet 67P on September the 30th, 2016. Rosetta's mission studied the composition, chemical makeup and dynamics of the comet, in the process opening a new window on the conditions at play when Comet 67P and the rest of the solar system were formed 4.6 billion years ago. But one question which Rosetta couldn't answer was exactly where Comet 67P was born. Now, using statistical analyses and scientific computation, astronomers at Western University have charted the path that most likely points to the very origins of Comet 67P Churyumov-Gerasimenko. The findings provide vital new information in discovering what kind of material the comet's made from and just how long it's been present in our solar system. The results are based on computations of the comet's orbital path both now and also going back into the past. It's a process which was computationally difficult due to the chaosity of the orbit caused by 67P's numerous encounters with Jupiter. While exact details are obscure, the research team were able to establish a dynamical pathway from its current orbit back to the Kuiper Belt, a ring of frozen worlds, comets and icy debris circling the Sun out beyond the orbit of Neptune. The data confirms that Comet 67P is relatively new to the inner parts of our solar system, having only arrived here about 10,000 years ago. Prior to this time, the comet was most likely inactive in the Kuiper Belt's frozen storage far away from the Sun. That means much of the material on Comet 67P has remained fairly unaltered by the reprocessing that occurs as comets come close to the Sun, where heat and radiation can start to cook and change a comet's chemistry. Previous studies have shown that similar comets, known as Jupiter family comets, historically stay in the inner parts of our solar system for only about 12,000 years. Therefore, recognising Comet 67P Churyumov-Gerasimenko as a member of the Jupiter family does make sense. The majority of Jupiter family comets are thought to come from the Kuiper Belt. The analysis shows that in transit, Comet 67P likely spent millions of years in the scattering disk, a distant portion of the Kuiper Belt about 60 times further away from the Sun than the Earth and about twice as far from the Sun as Neptune. As the name suggests, celestial bodies in the scattering disk tend to be thrown towards the inner solar system. This distant origin for 67P Churyumov-Gerasimenko implies that it would have been made from extremely primordial material, meaning minerals that existed in their current form since before the Earth was formed. There's growing evidence that China's getting ready to fly its new Long March 5 heavy-lift rocket. The new heavyweight launcher is capable of lifting over 25 tons into low Earth orbit. That's more than twice the capacity of the European Space Agency's Ariane 5 ECA, and roughly the same as the United Launch Alliance's Delta IV Heavy. When it does fly, the new rocket will be launched from the new Wenchang spaceport located on an island in the South China Sea. The Long March 5 stands about 60.5 metres tall, with a 5-metre diameter core stage. The core stage is equipped with two YF-77 rocket engines powered by liquid hydrogen and liquid oxygen propellants. The upper stage uses two YF-75D engines also burning liquid hydrogen and liquid oxygen. The Long March 5 has an estimated launch mass of about 650 tonnes and can be fitted with a range of strap-on boosters to meet specific mission requirements. The Long March 5 is the third of a new series of rockets, supplementing the long-standing Long March 2 and Long March 3 series launch vehicles. Beijing inaugurated the small-lift Long March 4 a year ago and followed that in June with their new medium-class launcher, the Long March 6. The new Long March 5 gives Beijing a long-sought-after heavy-lift capability needed to send large payloads into orbit for, say, a future Chinese space station and for mining projects on the Moon. The maiden flight, which could happen any day now, comes within weeks of China's successful Shenzhou 11 manned mission, which sent two taikonauts on a 30-day mission to the orbiting Tiangong-2 space laboratory, which itself was only launched in September. Three Expedition 49 crew members have returned safely to Earth following a 115-day mission aboard the International Space Station. The successful landing was also the first atmospheric re-entry of the new Russian Federal Space Agency Soyuz MS-01 capsule, which had been on its maiden flight. The charred and blackened Soyuz touched down under partially cloudy skies and temperatures of just below zero on the frozen Kazakhstan steppe. The new MS-series Soyuz spacecraft uses new onboard computers, new communications and avionics systems, a new Kurs NA approach and docking system, upgraded solar arrays, new propulsion and orbital maneuvering systems for attitude control, and additional shielding to protect the crew from space debris and micrometeoroid impact. However, the Soyuz still has only very limited cargo capacity, meaning the only significant piece of equipment returned to Earth aboard the capsule was the RAM, or Radiation Area Monitor. The Soyuz MS-01 had only docked to the orbiting outpost in July, making the mission significantly shorter than the 6-month duration flights usually scheduled. Their 1,840 orbit mission was significant in that it included the first use of a DNA sequencer experiment in space. The crew also conducted 2 spacewalks, and they welcomed the Russian Progress cargo ship and American SpaceX Dragon and Orbital Cygnus supply ships. The Soyuz MS-1 began its historic maiden atmospheric re-entry flight at 23:37 US Eastern Standard Time when it undertook a set of undocking and separation burns. The crew then conducted the 4-minute 37-second Soyuz deorbit burn at 23:06 Eastern, slowing the spacecraft down enough to cause it to begin falling back to Earth. 22 minutes later, as the Soyuz descended through an altitude of about 140 kilometers, its orbital and service modules were separated from the re-entry capsule. The new capsule's heat shield worked perfectly during the 2500-degree fiery re-entry, and the giant orange and white parachute deployed right on time at an altitude of about 10 kilometers to slow the spacecraft down.
Our first view of the Soyuz MS-01 spacecraft under its large orange and white main parachute.
We can confirm.
Just a moment ago, the heat shield being deployed. That enables the base, the bottom of the Soyuz with its altimeter and soft landing engines to be exposed. The altimeter providing altitude and rate of descent information to the onboard computers for the firing of the soft landing engines just a second or two before touchdown.
Search and rescue services, this is Irkutsk 1, standing by.
Search and recovery forces now have established communications with Anatoly Ivanishin aboard the Soyuz. The thick overcast that had been present around the landing site the last couple of days has broken just enough in the early Sunday morning hours in Kazakhstan to provide views of the Soyuz descending under its main parachute.
Guys, get ready, tighten it up.
All of the events, the deorbit burn, all of the entry timelined events have clicked off in perfect fashion. cameras that are on all-terrain vehicles at the landing site, picking up intermittent views of the Soyuz as it darts in and out of cloud cover.
Search and rescue services at Code 1. How do you copy?
Everything looking good. Search and recovery forces and all of the Russian Mi-8 helicopters associated with the Russian, U.S., and Japanese support personnel are now circling the landing zone in sequential fashion. They're all in place, standing by for touchdown.
The crew is feeling fine. Everything is fine on board. 2660 is the altitude.
The early morning Sunday sun glinting off the large main chute that is
Hello, crew.
carrying the Soyuz MSO-1, Anatoly Ivanishin, Kate Rubins, Takoya Onishi to a touchdown. Everything is in excellent shape and everything is ready on the ground for the recovery of the crew and the extraction of the 3 crew members. The Soyuz MSO-1 spacecraft drifting to its landing site to the southeast of the remote town of Jezkazgan. This landing sandwiched in between 2 launches, a frenetic pace of activity being carried out for the International Space Station's staffing of the complex.
334, right? Search and rescue services, this is at Code 1. 1,300 is the altitude.
Everything looking good. The crew reporting on board that they are feeling well.
Are your seats primed? Yes, affirmative. They are primed.
That reference to the angle of the seat positions for the 3 crew members in the Soyuz spacecraft for the firing of the soft landing engines that will take place just a second or two above the ground, a final braking maneuver to ease the jolt of the touchdown under the main parachute.
Altitude is 600.
One of the Russian Mi-8 helicopters, search and recovery helicopters, circling nearby the Soyuz spacecraft to get an up-close and personal look. They will be landing in rapid succession near the spacecraft once it touches down. Standing by for touchdown. Touchdown confirmed at 10:58 p.m. Central Time, 11:58 p.m. Eastern Time, 9:58 a.m. in Kazakhstan on Sunday morning. After a journey of 115 days and 48.6 million miles, the Expedition 49 crew is home. Anatoly Ivanishin, Kate Rubins, and Takoya Onishi. The Russian Mi-8 helicopters, part of the Rosaviatsa Search and Recovery Forces, are making their way toward the spacecraft. They'll land one by one. One of the first orders of business will be the erection of an inflatable medical tent nearby the spacecraft. Once again, touchdown time, 10:58 p.m. Central Time, 11:58 p.m. Eastern Time.
The 3 Expedition 50 crew members still on station will be joined later this month by 3 additional crew members slated to launch on November the 15th aboard the Soyuz MS-03 spacecraft from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. A new issue of Australian Sky and Telescope magazine has hit the newsstands. Joining us now with the details of this month's issue is the magazine's editor-in-chief, Jonathan Nally.
Yeah, now look, we've got some interesting stuff in the November issue of Australian Sky and Telescope magazine, starting off with Pluto. And of course, the NASA mission New Horizons flew past Pluto, about a year and a half ago now. It's just over a year ago. Quite amazing to think the time has gone that quickly. And the interesting thing about Pluto and the New Horizons mission is that, until New Horizons got there, we really didn't have any really good pictures of Pluto. So no one really knew what to expect. It's safe to say that a lot of scientists probably weren't expecting much out of Pluto because it's this little frozen, icy world right out in the middle of nowhere on the edge of the solar system where there's not a lot of sunlight, not a lot of heat, so you wouldn't expect to see much. But of course, it turned out to be an amazing place, one of the most amazing planets, or dwarf planet, as some people call it, in the solar system. And so we're running a series of articles in Australian Sky and Telescope about the different aspects of Pluto. And in this issue, we're talking about the geology of the place. And it's fair to say it really has surprised a lot of the scientists. So just for instance, there's that famous heart-shaped bright patch covering quite a lot of the dwarf planet, or the planet. I'm going to call it planet, Stuart. You don't mind, do you?
Oh, I'll grumble about it, but I'll put up with it.
Yeah, because I'm older than you, I think, aren't I?
I've got a few years on me, so I'll let you get away with it.
Us old people, we like to call it a planet.
Get off my lawn, you kids.
It's got this really bright patch, looks like a heart. Okay, so at first they thought, well, this is going to be a plateau. This is going to be some sort of upraised bit on the surface of the planet. It turns out it's not. It's actually a huge depression of sort of a lower area, probably 3 or 4 kilometres deep and about 1,000 k's wide. And it comes in two halves. It's sort of heart-shaped in two halves. One half is sort of rougher terrain, and the other half is really smooth. Now, scientists think that the smooth half is probably the remains of a huge impact crater. And there are some tall, icy mountains around the outside that sort of might be the last remaining evidence of that impact. Now, because planets are always being hit by meteoroids and the occasional small asteroid, and we're talking over thousands and millions of years here, you can often tell how old a planetary surface is by how heavily cratered it is from all these impacts. Now, that heart region of Pluto has, the smooth half, has almost no craters. It's really, really smooth, as a smooth half sort of implies. Now, that means that it would have been hit by things and it would have been cratered, but those craters have been eroded and erased away. So that means geological activity, right? Something's been going on in Pluto. That means Pluto is not a frozen, unchanging world, as many had assumed it to be. It means it must be still geologically active over geological time spans, thousands, tens of thousands, millions of years, which is pretty amazing to think that a place way out on the frozen edge of the solar system is still got geology going on. It's really quite tremendous.
And they've extrapolated that a step further. They think that could be signs of a liquid water ocean beneath the Plutonian, if that's the term, surface.
It is amazing, isn't it?
Whenever we look at an ice planet, we seem to find some evidence of not just frozen water, because you'd expect frozen water and ammonia and methane out there, but somehow below the surface something is hot enough, be it tidal heating, be it radioactive decay, something is allowing some of these tiny worlds, which should have cooled down long, long ago, to retain enough heat to keep water there liquid. And it's not just Pluto. You can think of Titan, the moon of Saturn, and Enceladus, of course. We also think orbiting Jupiter, not just Europa, which we discovered had a liquid water ocean years ago, but also Ganymede and Callisto. And Ceres, the other dwarf planet we often talk about. We think some of the craters under Ceres' surface may also have liquid water reservoirs beneath them.
It's amazing, isn't it? It really is incredible. All these things that we would have said years ago, it's impossible.
Still don't understand the heat source. What's causing this? In some cases, it is tidal friction, but in other cases, there's just no easy explanation for it. That's the mystery. That's what makes astronomy so exciting.
I think it's the aliens, Stuart. Yeah, the alien factories out there building the UFOs that are going to build the invasion fleet and come and get us. Oh, sorry, did I say that out loud?
You said that out loud.
Sorry. Just you'll delete that bit, won't you, before it goes to air? Yeah.
The men in black are monitoring us now.
Very, very good. Anyway, let's move right along then. What's else in the magazine? Okay, also in Australian Sky and Telescope, we've got a really good article. I really enjoyed this. A night with a big telescope. Now, Stuart, what's the biggest telescope you've ever seen through?
The one at the Sydney Observatory looking at Jupiter on the night of December 31st, 1999.
Was this the fake millennium?
Yes, it was the fake millennium, the one everyone celebrated.
Not everyone, Stuart. Not everyone.
You purists who waited for...
Purists? Do you realise people in 100 years from now are going to look back at some people who celebrated on 1999 and said, what idiots they were? What were they thinking? Goodness gracious me.
Prince would roll over in his grave.
What was he thinking? I mean, goodness me. I rember waking up that next morning thinking, looking around thinking, oh yeah, everything's still here.
What happened to Y2K?
Well, so they got the year wrong on that as well, didn't they?
They got that one wrong, the Mayan calendar.
I tell you, it's the aliens. They're ruining everything for us. So anyway, look, you're looking through a telescope at Sydney Observatory. Look, those telescopes at Sydney Observatory are pretty good. They've got some very nice gear there. I think they're probably a 40-centimetre telescope or something. Biggest I've looked through is 60-centimetre, which is pretty big backyard scope. Had a fantastic view of the Orion Nebula and a few other things through it. The more aperture you get, the larger the telescope, the more light it can gather in, so you can see fainter things.
You're giving me aperture envy.
Aperture envy. Oh, sorry to do that to you, Stuart, but you're using a term that astronomers use there, and you see all you can with that telescope, and then you want to see fainter and fainter things, so you've got to get a bigger telescope, and you know what it's like. Anyway, look, what you can do over in America is you can book time on what used to be the world's biggest telescope. This is the 100-inch or 2.5-metre wide Hooker telescope at Mount Wilson Observatory.
Oh, wow.
This was the biggest telescope in the world between 1917 and 1949. And if you've got a bunch of friends and you want to split the cost, for a few $1,000, you can book half a night on this telescope, which gets you that time plus a guide to help you out how to use it and everything. And you can go along and and look through a telescope that's got a mirror that's 2.5 metres wide. I mean, that's just spectacular. And it's in very good nick. They've refurbished this telescope, and amazing, huge metal beast it is. It's not one of these sleek, new, modern things they have these days. This is a real solid, enormous metal telescope. Really specky. So this bunch of people who wrote this article for the magazine, they booked half a night, about $2,700 I think it was, plus all your accommodation, that kind of thing. But if you split that amongst 10 of you, if you arrange to get along, it's really worthwhile doing to look through a telescope that big. So yeah, they went along and had a great old time looking at things like the Ring Nebula and the Saturn Nebula and the planets Uranus and Neptune and all sorts of other things, including objects that are usually hard to see because they're so faint. But for a telescope this big, it's a bit of a breeze. So yeah, you can read all about that in the magazine and find out how you can do the same thing if you're ever in the States and you want to look through what used to be the world's biggest telescope. And there's plenty more in this month's issue of Australian Sky and Telescope as well, including a review of a special mount that enables you to take amazing all-sky panorama photos with your camera automatically. You just sort of set it up and it will just do all the work for you. So that's pretty special. And also, similarly, we've got a review of some software, and we show you how to use this software called Auto Stack It, which is where you can, if you don't have one of these mounts, you can just take all these different pictures and stack them all together and produce one specky picture, and you get a better result by doing that with just taking one picture on its own. So lots and lots of interesting stuff. So that's what's in Australian Sky and Telescope for November.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGarry.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.
Your car to Carvana is as easy as...
As easy as pie?
Sure. All you have to do is enter your license plate or VIN.
As easy as a stroll in the park.
Okay, then just answer a few questions and you'll get a real offer in seconds.
As easy as singing.
Why not? Schedule a pickup or drop off and Carvana will pay you that amount right on the spot.
As easy as playing guitar.
Actually, I find that kind of difficult. But selling your car to Carvana is as easy as...
Can be.
Visit Carvana.com or download the app to get an instant offer today.